I'm really glad to see all of you here. And today I would like to talk about the document processing. We will talk about the classification approaches for the document classification themselves, and especially about the extraction of the information from those documents. So I'm currently lead of an LP team and working at Zero Systems. Our company, like the main goal of our company, is to work with the financial documents to transform the unstructured information into structured and to automate the workflow connected with documents. So it's mostly like financial and legal sphere. Yeah, about the overview, what we will talk about today, I will start with the task description itself. We will talk about the intelligent document processing, some classic approach, how we can classify the documents, how we can use NER, named entity recognition models and approaches to handle this extraction things. And then I will talk about new approaches. Some of them are not really new, but they're really work in zero shot, in few shot for classification and extraction. Then we'll talk about some ideas we include into our product, and these ideas are connected with the retrieval approach. And we will also talk about large language models and what now the difference between the previous type of extraction information from documents and how we can handle this now and what type of task we can handle. So the small introduction, as I said, I'm now the lead of an LP team. I also a lecturer of higher school of economics, and this is the university in Moscow. And yeah, I'm a master of computational linguistics. So let's first talk about the intelligent document processing. May I ask you to raise the hand who know what intelligent document processing is?
Okay. What is exactly, or what is our proposal,
but maybe your suggestion.
Too many aspects of this definition.
So I should say that's the main goal is to convert this unstructured information, this multi-pages documents with legal information, financial documentation and so on, into the structured data. And structured data, of course, will be stored somewhere, and of course we all know that the structured data is something that can give us insights about what's going on. Yeah, and and what we are trying to build here, it's yet another IDP solutions to classify and extract and somehow create business logics on top of the extracted information and help companies to save their money and for the people to save their time. So that was the initial goal. So let's start with the document classification. This is the basic task, I should say, and this is pretty solved. But of course, we can have a high accuracy of such system if you have a lot of documents, if you have properly defined the classes of those documents and so on. But in most of the cases, you have only a few samples, and you need to handle all of this. So the common problems of standard document classification approach is the document types distribution. For example, your task is about 20 classes or 50 classes or only 5 classes, and you need to somehow balance it to create a good system. Of course, this is now the best practice to use somehow the encoder from the transformer, like BERT or something else. It depends on your experiments, on your data, and yeah, you are just putting the first page text from the document, and you are trying to get the label of this document, and that's it. About the project we worked on, there is some additional requirements. We only have a few examples, for example, 50 documents per classes, and this was financial domain. It means that you have a lot of tables, you need to process them somehow, you need a lot of language specificness in these documents, and not all the models are working pretty good. Of course, I didn't put here any financial documents. Instead, we are using here Armenian fairy tales. So, because this is all fairy tales. So, Yeah, and let's move to the first approach for the classification, and this approach connected with the zero shot. So zero shot means that I merely ask the model to give me the type of the documents, and this is what we are doing now using APIs for ChatGPT and so on. But indeed, this approach was created a long time ago, maybe not long, but at least 3 years ago. Yeah. And what do we need here? We need to have a prompt, and we need to take the text from the first page or from multiple pages. And you see here, this is the multiple tasks, and all of these tasks are formatted in the same way. You see here the label, for example, positive sentiment, and you see here the text, and after this text. So what does this mean for the document processing? You can take the description of the document and then add the first page or few first segments from the documents, and just ask the model if this information are connected, these parts are connected or not. Yeah, and this is how you can handle the zero shot and even few shot approaches if you have only 50 labeled documents and M classes. So in this approach, we will just we'll create 200 samples for your model, and you can somehow retrain. Maybe freeze the part of the model, maybe something else. There is a lot of such technique, and I think you know about them. So yeah, this is how we can just augment our data using the approach itself. Yeah, and this is the first one. It's one that I should say this is the promising one. At least it was 3 years ago. Then we got this one. And this is the few shot approach for the document classification or the sentence classification. This is of course depends on what for which data you are applying this algorithm, and this is the set fit. Of course, it's presented in Hugging Face as the a sequence classification model we all use to them. So and set fit indeed a little more complex algorithm, but it also can resolve the problem. So this part is the new for the classification, and this part connected with the contrastive training. So what means here contrastive training? So example, you have the document number 1 from the class number 1, and you have the document number 2, and this is also connected with the class number 1. And what you need to do in this contrastive approach, you need to create such type of loss, so the embeddings of these two documents, if you will make a dot product of them, these embeddings will be similar, and that's it. And negative pairs you can also create from your data. This is document number 1 from class number 1, and this is document number 3 from class number 2. And of course, this embedding should be different. Yeah. And that's it about that set fit approach, because the only contrastive part of this approach is something that help us get the very good score, even if you have only 8 documents per class. Think about it, 8 documents per class, even if you have 50 classes. And this is something that really works, and I think you may have heard of this approach. And on top of this contrastive learning, you are doing the classic training of the classification head. It means that if you have 50 classes, you take the training for the classification head on top of this BERT model, because your sentence embedding or text fragment embedding were already good enough for this approach. I also put all the links here, so you can check them and use if it's needed. And so I think that's it about the classification of documents in our solution. So we can handle the classic approach based on logistic regression and TF-IDF, of course, if you need very speed engine for the classification. But if you can use GPUs, for example, and you can use the TARS approach, and you can also set fit approach, depends on the number of data you have. Because this one is for zero shot, and this one is for few shot. It means this requires at least 10 documents per class. And let's move on for most tricky part here is the named entity recognition. I suppose like the opinion in the data science field is that NER task is solved. I'm totally agree with this solution and with this approach, and we can have like a very high accuracy of extraction of the entities. But what if we are talking about the NER approach for the documents? And the main thing here is these entities indeed, and the density of these entities. So every time you want to teach the students about the NER task, you just take the Kono data sets where you have like only sentences, and in which sentence you have a multiple entities. It means that, for example, if I have like 10 tokens here, 10 tokens here, like half of these tokens will be connected, for example, with the person, organization, location, and so on. And this is all about the density. If we are talking about the extraction of entities from documents, you will have like 20-page documents and like 12 tokens from these 20 pages. And that's kind of problem for any type of algorithm, because the distribution of classes per each tokens is quite, I don't know how to say it correctly. So here we have this example and this named entity recognition approach, and it won't work if you have like 25 entities and like 10 documents or 20 documents, even if they're like properly labeled. So let's try to tackle this problem. Let's move to the QA. So QA, it's really a zero-shot approach. Of course, it's not so efficient. Your model will work less fast, but still. So about the architecture of QA, it's also the standard architecture. It can be based on the transformer encoder. You can use here like layout LM, and this layout LM approaches is also take into consideration the image and the layout of text on the document. So it means that, for example, layout will see the image on the text and will also see, for example, that it's the title. Yeah, that's like just feature engineering here. And the approach here, the standard one, we are trying to predict the start of the span and end of the span, and that's it. So, but what about the downsides of this approach? So it means that you need to process each segment of the document. So you will need to segment this part, this one, and this one. And you will have n question. So you have like 25 entities, and it means that you will need at least 25 questions, yeah, to extract them. And you will have m segments. So this is something that slows down your system and the whole product. Yeah. And we will have also plenty of false positive, because QA rarely generate no spans. It means that QA indeed do not answer like no answer. He always try to find something, especially if you like take the general model. There is like a very good one from the old days. It's Impera document QA model, and if you put this model into like financial or legal sphere, it's always trying to find something. If you are asking about the specific amount, he will give you all the amount, or at least the most probable amounts. And that's the problem. And of course you need to find it. And the last one is one question, one answer. So for example, my question is, can you please provide me all the data in these documents? Every QA model will give you only one answer for the given passage. Of course you can have like multiple candidates for the span. It means that you will have multiple starts and multiple ends. You can again reformulate your question to have another suggestion, but it's not working properly. But this problem we found the solution for it. So yeah, but like again, the most important here is plenty of false positives, because you cannot show to the user a lot of this such kind of stuff, because like all of this red bounding boxes or spans, they're not the right one. So we need to somehow handle this situation. And this is why we are moving to the retrieval approach. So for example, your query, provide a list with top 10 search engines. What's going on here? So we are like Googling this query. We are using for this even Google, Yandex, Bing, or Yahoo, anything you want. Yeah, and you're getting the top links. Yeah, and in some of these links you can find the right answer to your question. Yeah, and what if I take this idea, or I will take this inspiration and move it to the documents? For example, right now the whole internet is just one PDF file, and I want to query these PDF files if it has multiple segments, multiple pages, and so on. What is the document date? Yeah, and this is how I can like properly find the needed segments in which for this segment I will ask this question again using QA model, and that's it. So that's like, this is the really simple idea, but now you need to implement it somehow. And like the cross-encoder model, and why do we need here the cross-encoder model? Because cross-encoder model can be fine-tuned on the few samples, and it will show you the better performance. So how we can do it? Of course, having faith, we take the question, we take the text segment. So for example, if I have 25 entities and 50 segments, I will create this numbers of pairs, 25 multiplied by 50, and I will go through this cross-encoder model, and this is how I denoise the document itself. So I get rid of some segments from those documents which are irrelevant. And yeah, as I said, we just asking this question: relevant text segment to the question or not? And after the processing using the cross-encoder and denoise the document, we will get only the few segments here. And in these segments, I will find the needed information. And that's it. So this is how we can work in a few shot setup. So we discussed the document classification, we discussed the denoising approach, this cross-encoder model, and after this we are just like create the number, like we again asking the documents the same questions as we asked for denoising. Yeah, and yeah, that's it for these 3 steps. And like this is the main engine here, and why it is good or why it is bad. I should say that the part of the engine is to store the information from the user. For example, if I predict something wrong, I will ask user to verify, to change the label, and I will store this information. And when I will get like another 1,000 of documents processed, I will retrain the model using this human in the loop. I will use this feedback. Yeah, and the same thing for denoising and the same thing for QA. And it means that you're set up the product on premise on the client side, and you store the information about the verification result and retrain all these models. And that's it, how you get your performance become better and better when you process more documents. And some additional steps which can be presented in here. When we are talking about the legal sphere or the financial, we need to have a document converter because we want to get information from Word, from PDFs, from the Excel files, maybe from emails and so on. So it's like an engineering stuff here. We need to extract the text layer from documents because it can be scans, it can be documents without or with text layer. So and you can use here open source OCR models, for example. Sometimes you need to remove watermarks from the documents because it can decrease the quality of the whole service. And after this, you also can use the table parsing. And table parsing also is based on some open source model. You can represent the table in another flattened view, but we didn't talk about it. It's also part of the preprocessing. And the end of this pipeline, it's JSON file with the structured information, where some of the components can be retrained using the human in the loop. And that's it about the old approaches. This system, as you see, contains multiple transformers of different sizes. It can be the large, the small, the middle, and so on. But let's move to the large language models, And I should say that like all the approaches that's like open source try to use, they are presented here. Of course, do not like take it into production, yeah. But you you can see that's like Wikipedia of the approaches for the documents, for any other type of stuff. Yeah, and here like we also have this OpenAI and ChatGPT. So let's discuss how we can handle those tasks about the classification extraction with the large language models right now. And I took this classification from the LangChain, and there is only like 4 options, and indeed we already use MapReduce, yeah, and the approach I discussed about the denoising model, so cross-encoder and QA, it's all about the MapReduce stuff. But let's start from the beginning. That's like stuff approach. You just creating the prompts with all your questions about the document type, about the entities you need, and like putting the whole documents inside, if it is possible. And then you'll get the JSON. Another more interesting approach is refine. So you are creating the prompts. This prompt contains multiple questions. You try to ask the first segment of your documents. Maybe it's the first 2 pages, and you enrich your prompt. That's it. So you got some information from the first part of the segment. Then you may like skip some of the pages or something, but your prompt, it's like this is the same prompt, enriched one, and you like use this prompt for another type of for another segment of the document, and you get the final JSON. This is how you just like segmenting the documents, filtering unnecessary information, and putting this in a structured way using OpenAI or open source model if they can do this. But according to our experiments, like all the open source models, like we didn't take the Bloomberg, maybe it's a good one, but for the financial stuff or for the legal stuff, they cannot answer, they cannot extract entities, especially if we ask them multiple questions. I will show you the result later. So this is the MapReduce approach here. So you just take some first pages or first segments, you create a JSON from this one, the same prompt, and like another segment you will get another JSON, and like the third prompt just about merging the results, and that's it. So this is your final JSON. You go through even like 100-page documents. You might use API code, but of course like your bank account, the numbers on bank account reduce because you will like do a lot of requests in this approach. And this is the MapRerun, and it's nearly the same approach. You are asking the GPT, or you are asking the, for example, Llama model about this segment, you'll get the JSON. And this JSON is with meta information, and meta information connected with the confidence of the model. So for example, confidence for this JSON, 99%, and confidence for this JSON is 95%. And I have the manual threshold for this, and I'm just like skipping this results, and like that's it. This is my final JSON file, and this is the MapRerun. That's it. Also, like there is no spaceships in all this LangChain stuff. So just some ideas which were put it together, and this is why like this is your cookbook how to even work with documents and other stuff, maybe like videos or something. And some scores about the models and selections and like time on CPUs. Of course, like the top level LLM, I'm not sure like was it like Visa, Vicuna or something. And we have 2 kind of metrics here: the document level metrics, and it means that when I process the documents and I will show the suggestions of extracted document type and entities to the user, the first one, at least one of them were correct. And this is the score like on our pipeline, it's 83. Yeah, 83.5. And if I use some Vicuna model or Vicuna Visa model or something like this, in zero-shot approach, I will have something like this. Of course, if I will pre-train it, and as we all know right now, we will pre-train with LoRa or maybe with QLoRa, yeah, I will go to this result, and if it will be like 30 billions of parameters, I will got this result. Yeah, but indeed, like 3 points, especially if you are measuring like on the few shot approach, it means that you do not have like your validation set is not so big. It means that this is not really a different, and I cannot trust this result. And this is why like this is the last slide, just for you to like we evaluate those approaches and we evaluate like large language models, but it really means nothing here. So you have this documents metric, and you have also Rouge-L metric. It's the generation token generation metric, I should say. Yeah, we can compare it to sequences. And there is time on CPUs, and there is time on GPUs. Of course, like we did this only to fill in this table. We are not running the like the full 30 billion model on the CPU. So yeah, this is what we have right now. And the last thing I should say about all this models and denoising approach, like when we want to create a product for the clients, especially if like this is the legal firms, if this the financial firms and so on, like not this thing is taking the decision of what we will deploy. This thing and the cost of the CPUs, this is what will take the decision about the solution you will provide to the client. Because no one wants to take a GPU A100 to like solve the problem which can be like done manually. Yeah, given like if you use only like few persons to extract the information from documents. This is why when we are trying to build something for extraction or for classification, one of the core points is, or one of the key points is how much the compute resources you will need to inference all this stuff. And the second thing is that this pipeline can be trained on the client side. Of course, I will take maybe like 32 cores, maybe I will ask for 64 cores, but it's like CPU cores still. And to even pre-train the Llama for this on the client side, I would ask at least one A100 to handle this. So, and this is another problem here, and this is why right now we take this approach and not this one. And of course, quantization and so and like any other type of optimization will help us, but we didn't yet on this point, and we are still researching and investigating how we can do this in an optimal way. That's it.
So, am I correct? You just not using LLMs like for QA for now because it's worse than your previous approach?
No, it's not worse, I should say, because it's better.
It's worse on whole metrics.
No, so this is the metrics. This is the end-to-end metric, and this is also end-to-end metrics. But in terms of like numbers of parameters and compute resources, like we won't take this into inference because it's like 30 billion parameters. And here we have, you see, Liberta and Loyal. It's about, and there is also classification model based on sentence depth or something. Like all this pipeline is less than half of the billions of parameters. So, and it can be like run on CPU, and it also can be distilled somehow and quantized. So, why do we need to use this and ask for at least GPU with A100?
Yeah, that was my question. So yeah. It's just not feasible to use in production.
Yeah, it's
for now.
Yeah, it's just time. Like it's resource costly and resources. It's like we want to save money, not to spend money. Yeah.
Yeah. You did mention that you know the algorithm that take too much processing time, they are too expensive. And but if we were to compare the cost of manual processing, without any computing, and your approach, how much cheaper is it? Your approach, how much do you save? Is it like 100 times cheaper?
I see a point. So I cannot provide you the exact numbers. But I should say that, for example, if user take 10 or 15 minutes to process the documents, and if our system is performing this solution, or after the few iteration of training on the client side, right now we have about 90%, according to this metric, 90%. And so we got after 3 trainings, we got plus 5 points because we processed more documents. The time decreased from 15 minutes to 5 minutes. So, yeah.
What are the best document extraction LLMs among all with moderate price?
That's a tricky
I know
one.
only Contractor.ai.
Mm-hmm.
It is created here in AAA. But what other models are?
So right now we have indeed one good model, and it is connected with NER task. I forgot the prefix of this model, but it's 7 or 6 billions of parameters. It performs really good on different domains. I didn't maybe Bloomberg also can work with this type of things, but I'm not sure. Because it's also on financial documents, it was trained on financial documents. And there is this universal universal NER model with 6 billions of parameters. It's trained on all the QA and NER tasks which are presented right now in the open source. And it works, I think, I didn't add the metrics here, but it's about 50 or 60% in zero-shot setup. But the only problem is that for all of this model, I take the document and I ask multiple questions at the same time just to speed up the inference. And then I use universal NER model. I need to take the document text and then ask sequentially one question and then another and then another and then another. So the universal NER from this perspective is more accurate, but the speed is less because you need to have more steps of inference. And there is also a tricky part in this universal NER is that, so for example, you take the text from the documents, you ask the first question and get the answer, and then you again enhance your prompt as we discussed here. So after the first question, we enhance the prompt, and the new prompt will be with the first question and with the first answer. And this is how you even enrich the quality of universal NER if you are asking the same document. So I think this is the most powerful model right now. And because of the size and the number of data which were put during training.
So we go a bit out of time. Let's end Semen again.